and today I'd like to talk about Catalyst in AppKit, or as I like to say, the unholy merging of these two concepts. Briefly about me, I live in Germany. I work as a team lead engineering at a German social network called XING. I do also have a Twitter, of course, where under Terhechte. I know this is kind of difficult to pronounce. I write from time to time. I also have a website, terhechte.de, adventure.me, and I even have a podcast that some of you might know under contravariance.rocks. I also, for the past almost 2 years, have been working on my own presentation app, which is actually what you're seeing right now. And this app is written in Catalyst. And so I learned a lot when I tried to port this over to the Mac in order to figure out how this works best on macOS. And hence the contents of this talk. Before I continue, I would briefly like to talk about Catalyst and say that if you look at what the Catalyst and AppKit team have done, it's really awesome, because you have 26 years of AppKit legacy. The original Next Step version came out in 1994, and ever since this has over the time become into macOS 10. But what is AppKit today was started in 1994, and the same with iOS, which came out in 2007 and was probably conceived before that. So there's a lot of legacy in these two platforms, and merging them in the way that it is now and works now in Catalyst is fantastic. And it already works well for a lot of use cases. So having one code base for both platforms, that is really exciting. I just wanted to say that before I continue my talk and talk about all the limitations that Catalyst does have. So before I can actually talk about the limitations and AppKit and how to introduce it, I would like to briefly show you Hyperdeck so that you can see the things it does and the things it couldn't do if I hadn't reached out to AppKit. So without further ado, let me get out of the presentation and show you the app. Now, this is Hyperdeck, and it's basically a Mac app that is also obviously an iPad app, where you write presentations in Markdown. So here it says my first presentation, and I can go there and I can change the contents. And I can obviously bold things. I can add additional content, like for example, I can hit the plus button here and add, let's say, a quote that says, but beyond that, I can also do things like select the headline here, and then I have these popovers where I can basically change the font size, even though it's Markdown, or I can tell it to basically animate in by falling into the scene over the course of 1 second. I can do the same thing for slides. So for the first slide, I can basically select it here and decide how I want the content to be aligned. So I can say that certain things have to go to various sides. I can change the slide master, which basically allows me to define what the slide looks like when it starts. And I can do many more of these things. And I can change the theme of these slides by basically going here and selecting a different theme. I can search for content. I even, when I go here, have preferences where I have general settings for the editor or for the slideshow, where I can basically say, do I want to use the present as a screen, and so on. And finally, I can even take a slide and move it to a different position, and it will calculate it all out and modify the markdown. It also has great support for code and much more. When I want to present this, one thing that was really important to me is that the presentations give you an extra oomph. And so in Hyperdeck, a lot of things are animated that not necessarily are animated in a normal presentation app, like this. And then there's lots of additional settings that you can reach via this popover here, where you can change the headers and the footers, you can override animations, and many more things. I think that's enough about Hyperdeck, and it gives you enough understanding to see how this app has been built and where I'm using AppKit. So let's go back to the slides. Okay, if you want to learn more, you can find out much more on hyperdeck.io. Obviously, as it is a Catalyst app, Hyperdeck also runs on the iPad. And as you can see here, when I place the two apps next to each other, it looks distinctively like an iPad app, whereas on the Mac, it looks like a Mac app. And this kind of is the whole idea behind Catalyst, but nevertheless, it was actually quite difficult to achieve this, to get this very Mac-ish look on the Mac, but keep the iPad look on the iPad. That took a lot of time, and for that, I also had to reach into AppKit. So let's look at the agenda for today. First, I will briefly talk about some of the AppKit limitations that I experienced. Then I will generally ask whether you should actually add AppKit if you're planning to release an iPad app. Then I will talk about how to add AppKit. And finally, I will talk about some advanced integration topics that might be useful if you want to do more complex things with your iPad or Catalyst app. So let's first talk about the limitations. I think it's important to say that the limitations that I'm showing here are really the limitations that I experienced, and you will probably have your own limitations if you start working on this. So one of the things is that I wanted to show popovers if a user taps an icon in the toolbar. Now this sounds like something that should work, but it doesn't. And the reason for that is that the UI popover presentation controller that you have in your iOS app, it requires a source view or a bar button item. But the NS Toolbar in Catalyst, what it has are NS Toolbar items. And when you tap on one of these NS Toolbar items, then these can't be used for the popover presentation controller and the app will crash. Another thing is that you might want to have multiple windows. This is another thing that is very common on the Mac. As you can see here, we have the preferences window and then there's the font selection window. And these windows are distinctly different from the main window. And obviously, iPadOS has windows with UI scene, but these are really aimed more at having different document windows, where each window has the same content and structure. Whereas what we're having here is you have one document that might have multiple windows, and this doesn't work so well with Catalyst. It's also difficult to style these windows. And so for that, it's much easier to reach out to macOS and to AppKit to create actual AppKit windows. I found this much more feasible, and it also gave me more flexibility in creating windows that really looked Mac-like. Here's an example. This is the window where you can select what to show on the presenter screen and on the slideshow screen. And this is actually another example of something that doesn't work, because if you want to support multiple screens, then tough luck. On Catalyst, UI screen always has one screen, even though they are multiple connected to your Mac. And the reason for that, obviously, is that from the way the iPad works, screens are a very different concept. Imagine that on the Mac, a window can be half on one screen and half on the other screens. Things like that are very difficult. But a screen then, which is the AppKit equivalent, is only available to AppKit. And so if you want to reach out and go into multiple screens and support these, you have to go into AppKit. And then there's another list of things. I call them the 80-20 rule cuts, because really what it is each of you using Catalyst will probably run into something different that he needs. 80% of what Catalyst offers works great, but it's the remaining 20% where you will find something that doesn't work with Catalyst out of the box. That might obviously work in a future version of Catalyst, but today we don't have that. And today you would need AppKit in order to go and solve it. So here's my list of cuts. I wanted to offer font selection, which was kind of difficult. You can't really hide the pointer, and if you're running a presentation, you don't want to see the mouse pointer, but that doesn't work from Catalyst. Going full screen in a proper presentation mode where the menu bar disappears and the dock disappears, that also is not possible. Then I wanted to add Sparkle support so that users can update my app even though it's not distributed through the App Store. That also doesn't work without Catalyst, without AppKit. And then here's a funny one. The popovers you display in your app, they always start animated and open animated within Catalyst, even if you say animated false. And it took some trickery to disable that because I didn't want them to open in an animated way because there's a delay that makes it all a bit slow. If you want a search field in the toolbar, that isn't that easy. And then you might want to do something that only AppKit can do, right? You want to execute processes or run script from within your app, or maybe even XPC services. All this is kind of reserved for AppKit, and if you want to use that, you need to reach out to AppKit. Here's the final thing I would like to talk about. It's, I would say, sweating the details. On the left side, you see what happens when you create a menu from Catalyst and you fill it up with content. What you don't have are these icons. On the right side, that's the same with AppKit, and there you can have these nice icons that give the user additional information on what he wants to do. This doesn't work with AppKit, and for these small details, sometimes you have to reach out into AppKit. Sorry, this doesn't work with Catalyst. With AppKit, obviously, it works. So that brings us to another question. Should you even add AppKit? I mean, is this something Apple supports? Is this easy? And so if you do that, if you add AppKit, here's an example, and you reach out into some properties of NS window, for example, or rather UI window backed by an NS window, you get this error message. And it says, warning, the usage is being shimmed. This will break in the future. Please file a radar requesting API for what we are trying to do. This really is Apple's seal of approval saying this is the right path ahead for whatever you're doing, right? So we are on difficult ground here. It's kind of the worst of both worlds. You have the limited documentation on Catalyst merged with the limited documentation of AppKit. So the one is already not really well documented, the other one neither, and then you combine them. And you never know if things will work because Apple clearly did not intend it to work that way. They are not supporting this. And then it can also break anytime in the future, right? So whatever you're doing, Apple might change it with the next release and suddenly whatever you do doesn't work anymore. So all of this is difficult. I still had to do it. And maybe you also need to do it if you look into Catalyst. So for me, the reason was, and it's easy, a presentation app should really have a presenter mode where you can show a presenter on a separate screen. A presentation app should also, allow you to properly go full screen. And the presentation app should also hide the cursor. And once I already had the AppKit integration, because I needed these things, I could pile on top and allow other things that also made the app experience on the whole better. Nevertheless, I asked myself, and you should also do that, is the requirement you have, is it really worth adding the AppKit dependency? There's, for example, you can have a nicer search field with AppKit, but does that really merit adding this complexity, this hack that is very difficult to maintain? I would say no. And then, do you really need popovers for toolbar action? Isn't there maybe something else you can do? So obviously there are things you have to ask yourself. For me, I had to go the AppKit route because there were things that weren't really possible otherwise. Okay, so now that we talked about why you shouldn't add AppKit, and you probably think, okay, I'm not going to add AppKit, let me show you how you can do it, because maybe you want to do it, right? And also it's nice to know how this works. This is actually kind of easy. So the first step is you add a new macOS bundle target to your project. And then you create a Swift file in the bundle where Xcode will ask you if you want to add a bridging header. Obviously, you add that bridging header. Really easy. Then you create a Objective-C object, which is, for example, a controller in this target. And then you load this bundle and you initialize the controller, and then we're done. That's it. It's easy, right? See, that's how you add AppKit. All very easy. Well, not quite. So let me go into a bit more detail and show you how you can add AppKit support. The first thing is obviously to add the macOS bundle target. If you look closely, you will see that the new target dialog right here is on macOS. It's not on platform iOS, it's on platform macOS. And then we selected a bundle. Now that we created the bundle, we added a Swift file. In my case, it's main controller.swift. And this also automatically added the bridging header. Then we want to write our main AppKit controller. That is the one that we are communicating with later on in order to call into AppKit. So as you can see, we have the add Objective-C here. We give it a nice name. This is important because everything we do works with the Objective-C runtime right now. And then we add a new function in order to show that this works. We want to return the number of screens that are connected to this Mac. So we add a function here. It returns an integer, and it returns the number of screens in any screen. So that is the API in AppKit that we want to call from UIKit. Then we need to add the principal class to the info-plist file. The principal class is the one we just created. And the info-plist file was automatically created by Xcode just for us. And I'll zoom this in. So here we set in the info-plist the principal class to the sh main controller that we just created. Then we go to our UIKit target and we add a, let's call it adapter.swift, which is basically taking over the communication from UIKit to Catalyst to AppKit from the UIKit side. We also have to add the AppKit bundle to the frameworks, libraries, and embedded content of the target that we want to create. Otherwise, the bundle and the class and everything would not be available to us. Also, look at the blue arrow. Make sure that here the platforms you select is only macOS. You don't want this bundle to end up in your iOS target. Finally, now we go into UIKit and we load the bundle. Now we see the, I would say, most difficult code of this presentation, so bear with me. First, we create the name of the bundle. We put it in a variable so it's easy to access. Then we create a new class. This is our AppKit adapter. And then we have a lot of code. So let's go through this. First of all, this is a static variable that will return the principal class that we already defined just minutes earlier in AppKit. We take our bundle, that is our UIKit bundle, and we ask it for the bundle that contains the principal class, which is in our plugins bundle as part of the main bundle. And then we initialize it and we load the bundle. And after the bundle has been loaded, we can actually try to get the principal class out of the bundle and make sure that this is actually an NS object. Thankfully it is, because we did that right. Otherwise we return nil. Now in this case you could also crash or whatever you want to do, because obviously things are not working as expected when we end up here. Then you take your class and you return it. Now this is fancy, but what do we do with the class? So we want to initialize it. So the way we do that is here, again, we have our code, we initialize the class and so on. And then we keep a private variable for the AppKit controller. Now the type here is not our main AppKit controller, for example. This is NS object because UIKit doesn't know about the type of the AppKit class. We can't import it because they are fundamentally different. So we have to keep it very general. We take NS object. And then in load bundle, we take the class that we just created and then we initialize it by calling init on it. And that's it. Now our AppKit code is basically running within our app. Well, actually what's missing is calling it. So, and we do that by implementing our number of screens method that we have here. And so this one, we once again create the selector that we want to call, and now we call another Objective-C method, which is perform selector. It takes a selector, in this case number of screens, and it calls it on the Objective-C runtime, and it gives us back the result. And that one we want to print because we want to print the number of screens. Finally, we put it all together. We have to initialize our AppKit adapter somewhere so that it is stored and can continue to do the communication. And we make sure that we only do this on the Catalyst target, because on iOS, we can't do this. We can't really talk to AppKit on iOS, right? So when our scene is connecting, we once again check that we are on Catalyst, and then we initialize our bundle, and we call the number of screen functions so that we can prove whether this works. So let's run it, right? Right, this didn't work. We get a exe bad access, and whenever you get an exe bad access, you know it's kind of about memory maybe. So this is not optimal. So what's wrong here? What we're doing is we are using the Objective-C perform selector method, and this method really returns an any object because this is all the Objective-C runtime. It doesn't really care about value types, and we were expecting an integer, not an any object. And so in terms of memory management, when you communicate between AppKit and UIKit, you have to make sure that you can't just return value types. And that all communication between Catalyst and AppKit should really use NS object types. And there's a bit more on that later in this talk. We also have to make sure that we retain the objects that we receive from AppKit because they are not retained on the AppKit side for us. So let's fix this. What we need to do is we write a new number of screens method in the AppKit bundle. And instead of returning an integer here, we return an NS number. And then we have a main target again, or this is our UIKit target. And also here we change the method number of screens. So now what we do is we again take our selector, but now we perform the selector and then we take the retained value as an NS number, otherwise we return, and then we print the integer value in that NS number out that we got back. And now we have success. As you can see here, it says number of screens 1, and that is correct because there's only one screen on my MacBook. Obviously, you didn't need to remember all this. I have a demo project here on GitHub where all this is implemented, including a couple of other things that I will talk about in a minute. I will take a second for you to write this down if you're interested. And 3, 2, 1, let's continue. Now that we did that and we successfully were able to call an AppKit method from UIKit, let's talk about some advanced integration techniques. So first of all, you may want to access the NS window. The NS window obviously is the window that belongs to your Catalyst app, but in Catalyst it is a UI window. And this UI window on Catalyst is backed by an actual NS window. And that is something that you want to hand in to AppKit in order for AppKit to allow you to perform actions on this window. So what kind of actions, you wonder? For example, you may want to add popovers or work with menus. Or maybe you want to add child windows to AppKit. Or maybe you want to display custom UI. There's a variety of things you may want to do, but all of these things require that your AppKit app knows about the window. And getting access to this window is actually a little bit tricky. Thankfully, there's a great solution for that, and that is called Dynamic. Dynamic is a package that you can add with the Swift Package Manager, and it makes it really, really easy to access Objective-C APIs via Swift. It's using the dynamic member lookup and dynamic callable conventions, and it's really great. And fun fact, on their website, straight from their website, they have the explanation of how you can access a NS window from a UI window on a Catalyst app. Now, just briefly, you take the NS application, you access the shared application, then the app delegate, and then you ask it for the host window for UI window, which is actually a method that Apple implemented. And if you're on Big Sur, then there's another attached window, then you return it. And this is everything you need in order to get access to the NS window that you then can hand over to AppKit in order to work with it. The demo project that I have doesn't really do this, but there's lots of explanation in this package that you can just use. Another thing that you might want to look into is communication. And communication is everything that goes beyond calling perform selector as we did earlier. So you want your AppKit, for example, to notify your UIKit code. Let's say if a process is done running, or if some calculation you did in the background is done. Maybe you also have complex types that you would like to share between AppKit and UIKit, something that goes beyond strings. So the first thing is that we want to add a delegate to AppKit, something that AppKit can call to reach out back into UIKit. And here's an example of how you do that. There are many more possible because fundamentally everything the Objective-C runtime allows you to do, really, you can do. In this case, what I've done is I have a selector action, which is a Objective-C selector that is called action for selection. And then I have a closure which is only used for me to internally call on the AppKit side the selector without having to actually perform call selector. So we do that, and then we have a method. This one is accessible from the Objective-C runtime. This is the one that we call on the UIKit side in order to set a new delegate. And the delegate is just an NS object. We can't use protocols here because the protocol conformance on the UIKit side will not be understood by the Objective-C runtime on the AppKit side. We ask the delegate if it responds to the selector that we defined earlier. And this is important because this way we make sure, because we don't have the type safety, that the delegate we got in actually conforms and has these messages that we want to send. Otherwise, you could crash because obviously this is a programming error. Then we create this closure, and the closure internally, it performs the selector action with the parameter. This strips away the Objective-C runtime, and you have this closure which actually makes it easier to use. On the UIKit side, we have another function set delegate that we can call on UIKit. Once again, we have an object. Now here you could add protocol conformance. I've tried to keep it simple. We create a selector again, and then we call our AppKit controller to assign the delegate with the selector. Finally, we take another controller. In this case, it's a view controller, and we conform to the selector we defined earlier. We implement this method, and it says AppKit says hi. And this basically will be called on the UIKit side when something happens on AppKit. I have a brief demo here of something of a little bit more involved example. So let me go to Xcode. Okay, let's look at the demo. We have on the AppKit side a function show custom window that will open a AppKit window and will add a label and a button. And the button will say hello back. And when we tap the button, we call the UIKit function method that says hello from AppKit. It sends the string back to UIKit. And on the UIKit side, we have a button here that when tapped will show the window. And then when AppKit calls back to us, will set the content that AppKit sent to us back to the window. So let's try this out. Here's our button. It says hello world. And now when I tap it, we open a very, very beautiful AppKit window. And in this AppKit window, we have AppKit saying here, and we have hello back. And then when we tap it, we say back hello from AppKit. This is the content that we got back from AppKit. Okay, let's go back to the slides. Another thing you can do is just use NS notifications, which in my opinion is something that also works well. And you can also use, I personally prefer the delegates, but I played around with this and it worked well. And here's just an example. Obviously, you know how to send a notification, but here on the AppKit side, we are also just using NS Notification Center. We post something, it arrives on UIKit. Another thing you may be wondering about is, what about custom types? You don't just want to send strings around, right? So this is a bit more difficult. NS string, NS dictionary, NS number, and so on, like the typical foundation types, they work without a problem. But you can't really import the frameworks back and forth. So you can't import your AppKit framework into UIKit, and you also can't have a third framework that you import into both, because it's different, except if you make sure they work on both platforms. You could, for example, easily add one file to both targets, but even that doesn't work because the types are fundamentally different. So even though you have one Swift file that has a myFancy class, and you initialize it in both on the AppKit side and in the UIKit side, then UIKit will not be able to understand this class because the memory layout of the class is a little bit different, and it will all be confused. So the presentation is different. You can't just do that. So what you can do is you can take your type, convert it to JSON with Codable, and then send it over the AppKit UIKit wire. You can also try how far you get with NS dictionaries. And then you could also do NS coding. I didn't try that, I have to admit, which might also work, even though I'm not sure if the representation is the same. That's maybe something you could try. Which brings us to the end. And I hope you liked it. And if you have questions about this, then feel free to ask in the chat.